Okay, here we are with lesson 7, markup and markdown problems. And this is definitely something that you use in real life. So this has huge implications for math and the real world. So you're going to need a calculator to help you speed up your process with some of these problems. Alright, first of all we're going to take a look at definitions. So you'll need to make sure you write these in your math journal. A markup is the amount of increase in a price from the original to the new price. A markdown is a markdown of the amount of decrease in a price from the original price to the new price. The original price is the starting price. It is sometimes called the cost or the wholesale price. The selling price is the original price plus the markup or minus the markdown. So the markup or markdown rate is, the markup rate is the percent of increase in the price, and the markdown rate is the discount rate or the percent of decrease in the price. Most markup problems can be solved by this equation. The selling price is equal to the quantity of 1 plus m times the whole, where m is the markup rate and the whole is the original price. Most markdown problems can be solved by this equation. The selling price is equal to the quantity of 1 minus m times the whole, where m is the markdown rate and the whole is the original price. Alright, so in your journal, let's consider the following problem. A brand of sneakers costs $29 to manufacture in Omaha, Nebraska. The shoes are then shipped to shoe stores across the country. When you see them on the shelves, the price is $69.99. How do you think the price you pay for the sneakers is determined? Use percent to describe the markup and explain your reasoning. So we're going to go ahead and step through this. So the store makes up a new price so that they can make money. The store has to buy sneakers and pay for any transportation costs to get the sneakers to the store. The store marks up the price to earn a profit because they had to buy the shoes from the company. And the markup is the amount of increase in a price from the original price. So this is how the price of an item sold in a store is determined. In order for the manufacturer to make a profit, the store has to pay the cost to make the item. Then, a store purchases the item at a cost price from the manufacturer. The store then increases the price of the item by a percent called the markup rate before it is sold to the store's customers. Stores do this to earn a profit. So, let's look at example 1 on your lesson worksheet. Games Galore Superstore buys the latest video games at wholesale price of $30. The markup rate at Games Galore Superstore is 40%. Use your allowance to purchase the game at the store. How much will you pay, not including tax? So for part A, we're going to write an equation to find the price of the game at Games Galore Superstore and explain your equation. So again, going back to your notes, look at which equation is going to fit the situation. So you can pick any variable, but they've decided to let P represent the price of the video game. And then using our equation, quantity is equal to percent times whole. P is going to be 100% plus 40% times 30. Now remember, this matches with the 1 plus m. It's just since we still have it in percent form, 1 is 100% and m is 40% for our markup. So it'd be 100% plus 40% and then that quantity times 30. So the equation shows that the price of the game at the store is equal to the wholesale cost, which is 100% and 40% increase. This makes the new price 140% of the wholesale price. So now we're going to solve the equation from part A. So if we do that, there's a couple different ways. You could do 100% of 30 and then 40% of 30, or we can simplify in between, use our order of operations and simplify within the parentheses. 100% and 40% is the same as 140%, or 1 and 40 hundredths, since we need to convert it to a decimal in order to calculate. So 100 or 1 and 40 hundredths times 30 is 42. So that means I would pay $42 if I bought it from Games Galore Superstore. So what was the total markup of the video game? Well, the markup was $12 because $42 minus $30, which was the original price, is equal to $12. You and a friend are discussing markup rate. He says that an easier way to find the total markup is by multiplying the wholesale price of $30 by 40%. Do you agree with him? Why or why not? Well, you should agree with him because 40 hundredths, which is 40% converted to a decimal, times 30 is 12. The markup rate is a percent to the wholesale price. Therefore, it makes sense to multiply them together because quantity is equal to percent times the whole. So which quantity is the whole quantity in this problem? Well, the wholesale price is the whole quantity, which is $30. So how do 140% and 1 and 4/10 correspond in this situation? And as I said before, the markup price of the video game is 140% times the wholesale price. 140% and 1 and 4/10 are equivalent forms of the same number. In order to find the markup price, we have to convert the percent to a decimal or a fraction in order to work with it, and then multiply it by the whole. Remember that percent is just a shortcut way to write a fraction. So what does markup mean? Going back to your definitions, a markup is the amount of increase in a price. All right, let's take a look at example 2 on your lesson worksheet and step through this. So a $300 mountain bike is discounted by 30% and then discounted by an additional 10% for shoppers who arrive before 5 a.m. For part A, we want to find the sales price of the bicycle. So what property allows us to solve this problem in one step? Hopefully you said the distributive property. Instead of multiplying and then subtracting, we can multiply by the difference of the whole and the discounted percentages. Does it matter in what order we take the discount? Why or why not? Well, the order does matter because applying the first discount will lower the price. Then you would multiply the second discount to the new lower price. So in this case, adding 10% and 30% to get 40% is not going to help us. And you'll see why here in just a second. But the order doesn't matter because both discounts will be multiplied to the original price anyways. And multiplication is commutative. For example, 2 times 3 times 4 is the same as 3 times 4 times 2. So let's see which or both statements are correct. So let's find the sales price of the bicycle. Well, applying the 30% discount, that means that we would do 100% minus 30%, or 1 minus 3/10 or 30 hundredths, and that would give us 70%, or 70 hundredths. When we multiply that by 300, we get 210, which $210 is the discounted price of the bicycle with a 30% discount rate. So which quantity is the new whole? Now that we've solved the first part of the problem, what is the new whole number? Well, now the discounted price of 30% off is the whole number, which is $210. So it's no longer $300 because we've already applied the first discount. So our new whole is 210. So now we're going to find the price with the additional 10% discount. We're going to let A represent the discounted price of the bicycle with the additional 10% discount. So again, since it is $210 is 100%, it is still 100% minus 10%. So when we do that, 100% minus 10% is 90%, which is 90 hundredths. When we multiply that by 210, we get 189. So $189 is the discounted price of the bicycle with the additional 10% discount. So for part B, in all, how much has the bicycle been discounted in dollars? Well, first we had $300 was the original, and now we have a new price of $189, so the difference between the two is $111. So the total discount is $111 because it was from the original price of $300. So after both discounts were taken, what was the total percent discounted? Again, if you think it's 40%, you are wrong. But its final discount of 40% means that you would add 30% and 10% and add it to the same whole. But this is not the case because the additional 10% discount is taken after the 30% discount has been applied. So what you're doing after that 30% discount is you have a new whole number, and that changes everything. So you are only receiving that 10% discount on 70% of the original price. A 40% discount would make the final price $180 because 180 is equal to 60 or 6/10 times 300. That's if you applied 40%. So notice the difference. The original price, or our discounted price, is $189. If we made it 40%, now it's only $180. So however, the actual final discount as a percent is really 37%, not 40%. So let's take a look at that. Let P be the percent in the sales price, or what the sales price is, of the original price, and let F represent the actual final discount as a percent. So if our part is $189, our percent is what we're looking for, and the whole was 300, then when we multiply each side by 1/300th to isolate P, we actually get 63 hundredths, or 63%. So 100% minus 63% is 37%. Remember, it is not 40%. So another way to look at this is to multiply the original price by 0.7, which is 70% of the original price, and then again by 0.9, because you're taking 90% of the second price. So if that's the case, then 7/10 times 9/10 is 63 hundredths, and that is the same as 37%, which is 100% minus 63% is 37%. So there's two ways we can go about proving that it is not 40% and that you cannot add 30% and 10% and then figure that out. So instead of purchasing the bike for $300, how much would you save if you bought it before 5 a.m.? You would save $111 if you bought the bike before 5 a.m. because $300 minus $189 is $111. Alright, so let's take a look at doing some exercises on your own, exercises 1 through 3. Complete the exercises, and again, use the formula quantity is equal to the percent times the whole. Use your calculator to speed up your work so that you're not spending too much time on it. And then check your answers by continuing the video. Okay, you should be done with exercise 1. So here is the answer to exercise 1. Check your work. Your work again might be slightly different than what they're showing here, but your answers should be the same. So the answer to number 1 is what you will save is $12.65. All right, go ahead and try number 2. All right, you should be done with number 2. So the retail price of the clubs is $750. Make sure you are reading the question. What is the question actually asking for? Because these problems, you can come up with several different pieces of information, but you got to come up with the information that answers the question that is being asked. All right, go ahead and do number 3. And the answer to number 3 is the percent increase is the same as the markup. Again, if there's anything that is confusing, make a note of it and bring it to class. All right, let's take a look at example 3. A car that normally sells for $20,000 is on sale for $16,000. The sales tax is 7.5%. So, what is the whole quantity in this problem? Well, the whole quantity is the original price of the car, which is $20,000. So what is the original price of the car, or what percent of the original price of the car is the final price? Well, if the quantity is 16, because that's our part, and the percent is something we're looking for, and 20% is the whole, then multiplying both sides by 1 over 20,000 to isolate P gives us 8/10. Well, 8/10, if that's a percent, is the same as 8 over 10, but we need to make it into 100 so that we can get the percent part, so it'd be 80 over 100 or 80%. So the final price is 80% of the original price. All right, so now we're asked to find the discounted rate. Well, that's easy, because if it was 80% of the original price, then that means the discount rate is 20%, because 100% minus 80% is 20%. By law, sales tax has to be applied to the discount rate. However, would it be better for the consumer if the 7.5% sales tax was calculated before the 20% discount was applied? Why or why not? So let's take a look at that. So let's say we apply the sales tax first. All right? That means the 100% plus the 7.5% times 20,000. Is 1.075 times 20,000, which is equal to 21,500. Now we're going to apply the discount, which is 20%. So if we do 1 minus 20%, that would be 0.8 again, times 21,500 is actually going to give us 17,200. So $17,200 is the final price, including the discount and the tax. So let's compare that to applying the discount first. So if we do 100% plus 7.5% of 16,000, then we would have 1.075 times 16,000, and our price would be 17,200. So what do you notice about this price and this price? Well, because both final prices are the same, it really doesn't matter which is applied first. This is because multiplication is commutative. The discount rate and the sales tax rate are both being applied to the whole number, which is 20,000. All right, so for part D, write an equation applying your commutative property to support your answer in part C. And it doesn't matter. $20,000 times 1.075 times 0.8 is the same as 20,000 times 0.8 times 1.075. All right, taking a look at exercises 4 and 5. Write a markup or markdown equation based on the context of the problem. Use the algebraic equations in the form of the quantity is equal to 1 plus m times the whole number for markups, or the quantity is equal to 1 minus m times the whole number for markdowns. Remember that the 1 is equal to 100%, but because you need to convert the percent to a decimal number, that's why they just leave it at 1. Right, when you are done with exercise 4, go ahead and check your work. All right, so you should be done with exercises 4. You're going to use your equations to make a table and graph in order to interpret the unit rate. And you may want to use a calculator for the calculations, but your equations and steps should be shown for these exercises. All right, so here's exercise 4. Write an equation to determine the selling price in dollars of the item that is originally priced as $S after a markup of 25%. So So remember that P is equal to 25% plus 1 or 1 plus 25%. It doesn't matter which way you do this, but this would be the equation that you're using, either one of these. Then create a table showing 5 possible pairs of solutions to the equation. So you can pick whatever you want. They did these, and this is what comes up. But as long as you are applying this formula to whatever price of the item, then you should come up with an equal or equivalent price after the markup. When you create and graph the equation, you have a proportional equation that should be marked similar. Your points might be in a different place, but you should still have a straight line. So interpret the points 0, 0, and 1 are, which should sound familiar because we did this in Unit 1. So point 0, 0 means that $0 or a free item will cost $0 because the 25% markup is also $0. The point 1 and R means 1 and 25 hundredths because a $1 item will cost $1.25 after it's marked up by percent, and R is our unit rate. So as we add dollars to the price of the item, then it is going to increase $1.25 for each of those dollars. All right, exercise 5. Go ahead and compare your answers. M should be 0.20 or 20%. So the markdown rate is 20%, and you can use that to check with all of the other answers. All right, let's wrap this up. So how do you find a markup and markdown of an item? Well, to find the markup of an item, you multiply the whole number by 1 plus m, where m is the markup rate. And to find the markdown rate of an item, you multiply the whole number by 1 minus m, where m is the markdown rate. So discuss 2 ways to apply 2 discounted rates to the price of an item when one discount follows the other. Well, in order to apply 2 discounts, you must first multiply the original price, or the whole number, by 1 minus the first discount rate to get the discount price, or the new whole. Then you must multiply by 1 minus the second discount rate to the new whole to get the final price. For example, to find the final price of an item discounted by 25% and then discounted another 10%, you would first have to multiply by 75% to get the new whole. Then you would have to multiply the new whole by 90% to find the final price. Another way to apply 2 discounts would be to subtract each discount from 1 and then find the product of these numbers and the original price. So if we look at that same example above, we would actually multiply 75 hundredths times 9 hundredths times the whole number. All right, we'll see you in class.